Zoom it, please. So I am taking a much smaller section here. External budget and showing very preliminary analysis. I am showing very preliminary analysis over a western part of Indus region. I am not going in much details of interaction, mid-latitude and all. So it's a very complex region, as is already so topographically intense. We have a merging of mid-latitude WDs in winter, and in summertime we have enough moisture in the vertical atmospheric column in the southern portion of the Indus basin, and by virtue of that there is definitely a kind of mid-latitude and summer interaction taking place over this region. So I am kind of focusing only on the estimated water budget over the Indus region and how this region is going. The codex is given by Dr. Krishnan only. We use that data, and out of that set of data I am only using REMO because it has the vertical label data available, which other set of data we don't have. So to have to see vertical atmosphere, because what's happening in particularly this region, as he also has mentioned, that atmospheric is kind of closing down and few mechanism probably is kind of a how the snow albedo and all those factors are playing role. There is a issue of the long wave radiation coupling, which is leading for Karakoram anomaly. People are calling it anomaly, and lowering of lifting condensation level. So what happening in that case, whatever the moisture is coming, incursing over the Karakoram region, it's kind of a dumping because it's already Karakoram or this region is at higher Himalayas, it's higher elevation, so your precipitation mechanism is much faster. So the precipitation mechanism along with the snow albedo, latent heat flux, and of course people are talking of aerosol also, but there is very less measurement. So I am limiting with certain model results and comparing with this. So this is the precipitation biases. If you look at the lower value over the Karakoram region, model is showing more precipitation. It's primarily due to the orographic forcing interacting with the flow, which is coming either the mid-westerlies or the Indian summer monsoon region. Whereas if you look the lower riparian region of the Indus lower region, you have particularly in case of March, April, May, you have the less amount of precipitation in the model environment. Of course, model has the cold bias, which I'll show in the next. Particularly, this is very interesting in monsoon time. Your atmosphere has a lot of moisture incursion is coming over this region. However, when you look at the trend, it is drying off, particularly in these 100 years or 120 years. This is the observation I am showing here with the model, observation model and the bias. And particularly in this different set of models in 2.6 and 8.5, I have taken two extremes of emissions. In those two extreme of emission, how the seasonal variation in the precipitation trends are changing. So over the upper Indian region basin, we have an increased amount of precipitation, but as it goes down towards the lower Indus basin, we are having a drying up in the model environment, and that's what we see in the whatever available data. One thing is very importantly to mention it here, that this region is very data paucity, data observation is not there, and that's what we are doing. One special volume of regional environmental change for IPCC 2018. So anybody if is interested on the Indian side of Himalaya, not Chinese have a lot of work already been done. So if anybody is interested to contribute for filling up this IPCC gap, also can contribute in that regional environmental change volume. For that will add on whatever the gap and whatever the understanding we have. So please look at that regional environmental change as severe general, and you can submit that. Rightly said, precipitation also over this basin has not much changes, but of course one thing I want to caution here, that we are averaging the whole Indus basin. In this lower Indus basin also, which is drying, it also getting cancelled out with the precipitation we are getting our region. But I am taking the complete Indus basin as a unit because the model has its coarser resolution. We cannot run at finer resolution. Coming to the temperature, it's a warming is showing here higher temperature in observation particularly, and higher elevation we have lesser temperature. Of course there is elevation dependent warming, but then again elevation dependent warming has a very critical findings. In the same latitudes, all the elevation dependent warming are not same in all the mountainous region, Alps, Rocky, if they are falling. So they are very controversial, contradictory findings people have proposed, that somewhere the same latitude you have the elevation dependent warming, higher elevation are warming much more, but in the same latitude other mountainous regions are showing cooling also. So this is very conflicting. So it's very regional dependency is there, and what Krishnan has proposed for Himalayan region is absolutely correct. In Himalayan region, as you go higher up in the Himalaya, upper regions are warming rates are faster, and in between where there is a cloud forming process is taking place in that elevation, there is a kind of a kink comes because this cloud is kind of a stopping and it's decreasing the warming. So roughly 3000 meters what we found that you have a slight kink where the decrease is taking place, and again the higher Himalayas, then where the clouds are not forming, it's beyond the cloud forming zone, you have the higher warming rates. So when we are talking in this RCP 2.5, we distinctly see there is a role of moisture temperature interaction. I am not talking precipitation. Precipitation mechanism is much complex. So I am discussing mostly moisture temperature interaction. When you have more moisture in the monsoon month is coming over the region in summertime, it may precipitate, but I am considering only the moisture which is available in the free atmosphere. It may not precipitate. So precipitation is effective what we receive at the earth's surface. So particularly this time, this moisture is a kind of cooling in the monsoon month. The comparative warming is not as winter as the post-monsoon, whereas it's kind of lessening in both the RCPs, both pessimistic as well as optimistic RCPs. And you here see that historical run, present and future in different regions, in different RCPs and in different seasons. So definitely warming is there. We cannot deny that warming is not taking place, but the major focus of this is why the water budget and how the water budget over this region is taking place. So we looked into the possible available variables in the model results. I'm only showing the model results here, very preliminary though. We found that there is a higher evaporation is taking place from lower Indus river basin. So evapotranspiration is a negative, it means that it is going more up in the free atmosphere, right? So it's going up in the free atmosphere. So lower Indus river basin is drying, whereas the upper Indus have less evapotranspiration. Of course, temperature is the instrumental for the evapotranspiration mechanism at the surface level, and of course sensible heat flux corresponding snow albedo, which is more instrumental over the upper region than the lower region, because you have more snow at the higher elevation. So your snow albedo feedback mechanism is more dominant there, and hence you have a lesser evapotranspiration taking place. And we have also done with some kind of a different kind of a snow debris and all those. I am not showing the emissivity values leading to different kind of a snow mechanism. And these are the trends. If you look at the trends, but in the 8.5 scenario, you have very high evapotranspiration is taking place, and that is another reason also linked to that the moisture, whatever is available, it gets released in the free atmosphere. Snow melt is higher here. Of course, we have more snow here, so snow melt must be in the higher Himalayan region rather than the lower region. So snow melt is more over the topographical region of Karakoram, and that's what is the region of Karakoram anomaly. I am not trying to say anything on Karakoram anomaly here, but I am limiting over on the river basins, in Indus basin here, how the snow melt is taking more here and lower region, and melt of snow is primarily more in the seasonality is there in March, April, May. That's what I was requesting Dr. Krishnan, that we have to be look into the seasonality, because it's a very distinct signature. If you look into this, if I shift the March, April to the winter, our kind of interpretation seasonality will change, because winter flows move towards northward because of the warming of the southern continent. So you have a subtropical westerly jet which carries the WD. It kinds of moved over Russian region. So WDs are not approaching. Of course, there is a freaky incident like Uttarakhand event happened. So when WD came much lower. So there are very rare events which are happening there. But otherwise, in March of April time, your subtropical westerly jet moves much northward, and hence you have lesser precipitation as far as the seasonality is concerned. Trend is there. You see here is less snow melt trend I am talking comparatively here. So the western side of Himalayan region is having more evaporation, less evaporation than the upper side, because that's the front which faces the incoming western disturbances here, and which is the front which takes more of the snow along with that. Hence you have more snow melt is taking place there. Decreasing trend is seen in the 2099. We have bias corrected some of this data, but not all, because we have not real-time observation at the station time. If you see runoff is higher here as compared to this, and this is one important aspect maybe the glaciologist or snow researcher can take off, how the runoff is affecting this region of Indus river discharge, and like that to continue with the upper Riverian river. And maybe the geopolitics is coming here because of the two countries are kind of linked to this river basin of Indus here. Seasonal mean rainfall flux in the long term is here. It's increasing the seasonal mean rainfall flux over the higher elevation, which is much lesser in the lower Indus river basin. Specifically coming to probably last slide, that's what the water storage we are trying to calculate over Indus river basin. That what we are concluding that because of two primary reasons. One is the northward propagation of monsoon is decreasing. It's kind of a dampening. The monsoon is not going much northward, and there are findings like that. And because of that, there's less moisture is propagated northward. That is one reason that lower IRB region, Indus river basin, will be more drier than the higher. And particularly WD, as Madura et al., his group has shown that we have more number of WDs is coming. So it means that we are receiving more amount of precipitation over this region. By virtue of this region, we have more water storage here, but the lower riparian region of the Indus river basin will in course of time will be more drier, one because runoff is more. So, and another thing is monsoon is not approaching, so there will be more drier will take place. Temperatures are increasing, so all the conducive condition mechanism is kind of a leading that lower Indus river basin will be more drier in coming time, whereas the upper Indus region will have comparatively higher water storage. Oh, this is the trend. If you look at this trend, so here is the positive trend coming in the different season also, and in the higher region the trend is still negative. So the water storage will be more. So this is what we are doing. We are trying to now trying to calculate the precipitation mechanism, though it's very complex and it's yet to be understood, because none of the model are able to divide when there will be liquid precipitation or a solid precipitation, when the liquid precipitation will densify. So that mechanism is kind of very important, particularly when we are talking about snow albedo feedback mechanism, which is kind of affecting this mechanism at the surface level, land use level, number one. And number two is very specifically, if you see subseasonal variability of winter precipitation, if you have more precipitation in December, you will be having lesser precipitation in January, and you will have more precipitation in February. Or on other way, if you have a less precipitation in December, you have higher precipitation. So there is a very strong subseasonal variability is also taking place in the Indian winter monsoon. Why I was telling Indian winter monsoon is that we have done this study and tried to define Indian meteorology. It took me longer time to establish this term Indian winter monsoon, because we have shown that also from paleo records, and distinctly we try to define this with northeast monsoon. We try to distinctly define it. I have a heated debate with late Dr. Sikka. Finally he agreed, and he is one of the author of that paper. So that's what I want to say, and thank you very much, sir.